Welcome to the video, welcome to the conversation. It's a brand new day, it's a brand new topic. We're going to be talking about fractions, specifically equivalent fractions. We're going to be answering the questions of what are they, why do we need them, and when would we use them. So grab your pen, grab your notebook, and grab your favourite beverage. Come and join me, and we're going to get started. Our objectives in this video are to be able to use equivalent fractions, to be able to identify the biggest fraction, and also to be able to use equivalent fractions to order a set of fractions. As always, we have a few questions that we need to be asking before we get started. The first one is, what is an equivalent fraction anyway? How do we find an equivalent fraction? And why do we need them, or where would we use them? We're going to be exploring these questions and answering them along the way. So what is an equivalent fraction anyway? Well, an equivalent fraction holds the same value as another fraction. It is just written in a slightly different way. Let's look at an example, and here we can see we had a pizza. It was cut into 4 equal sized parts. We have 3 parts remaining. Presumably we've eaten one of them. So we have 3 out of the 4 parts, or 3/4 if you prefer. Now, not all pizza shops will cut that up into 4 equal parts. Some pizza shops like to cut it up into 8 equal parts. And here we can see out of the 8 equal parts, we have 6 parts remaining. So 6 out of the 8, or 6/8 if you prefer. Now, if you just look at the shape, what we can see here is we've got the same shape of pizza left. So we've got the same amount of pizza remaining, because we've had a quarter of each pizza has been eaten, or in this case, 2/8 has been eaten. This is what we call equivalent fractions. 2 different fractions that have the same value. So these are equal to each other in value. All we've done is we've multiplied by 2 at the top to get 6, and by 2 at the bottom to get 8. How do you find an equivalent fraction? Well, we just demonstrated a little bit of this on the previous slide. One thing we did not yet discuss was the golden rule. The golden rule is simple. What you do to the top, you must do to the bottom, and vice versa. So what you do to the numerator, you must also do to the denominator, or what you do to the denominator, you must also do to the numerator. As you do this, please do bear in mind when we are working with equivalent fractions, we can only multiply or divide. We should not be adding or subtracting. Let's take a look at an example. If we start off with 1/2, okay, if I, for example, multiply the top by 2, I get 2, so it's 1 times 2 is 2, but if I times the top by 2, I must times the bottom by 2 also. So we can see here that these are equivalent fractions. 1/2 is equal to 2/4, in other words. Let's just take a look at the inverse of this in example 2. So we're going to start off with 2/4, we're going to turn it into 1/2. Now to do that, I can't subtract 1, for example, 2 take away 1 or 4 take away 2. What I have to do is divide, and I divide by 2. Now remember, if I divide the top by 2, I must also divide the bottom by 2. The golden rule is what we do to the top, we do to the bottom, or what we do to the bottom, we do to the top. So it's at this stage where we offer you an opportunity to skill into practice by completing a few questions of your own. So please do make sure you press pause, you give yourself plenty of time to copy and complete the following questions, then press play and we'll work through the answers together. Okay, press pause now. Okay, hopefully you've given yourself plenty of time now to work on these questions. If you haven't, please remember it's not a race. You can take as much time as you like. Press pause again. Okay, let's just take a look at this together now. Question 1. 5/8 is equal to something over 24. Well, since I already know that 3 times 8 is 24, it means we must have multiplied by 3 to change 8 to 24. Now remember the golden rule. What we do to the bottom, we must also do to the top. So 5 times 3 is going to give me 15. Let's look at the second question. I know that 4 times 4 is going to give me 16. So remember, what I do to the top, I must also do to the bottom. Or we could say what we do to the numerator, I also do to the denominator. So we have to multiply the denominator, or bottom value, by 4. 7 times 4 gives me 28. Third question. Something over 5 is equal to 10 over 50. So instead of multiplying, I'm going to divide. I'm going to try and change the 50 down to 5. So if I need to divide that by something, I would divide by 10, because I know that 5 times 10 is 50. So 50 divided by 10 will take me back to 5. So if I've divided the bottom by 10, I must divide the top by 10, because our golden rule tells me what I do to the bottom, I must also do to the top. This is going to give me 1 over 5 is equal to 10 over 50. Our third question, or our fourth question rather, I have 9 over something is equal to 36 over 48. So we are moving from 36 to 9. And the only way we can go from a bigger number to a smaller number is divide. And since I know that 4 times 9 is 36, then I've obviously taken the 36 and divided it by 4 to get 9. So what I do to the top, I must also do to the bottom. Remember our golden rule. And we're going to divide the 48 by 4, giving me 12. Last part. Which of these fractions are equivalent to 1/5? So we go through the same process. We're going to cancel these fractions down and see what we can get. So we're going to try and get 1 on top. So it's the same as saying equals 1 over something. Equals 1 over something. 1 over something. Equals 1 over something. Okay, let's start with D. To turn 6 into 1, I would have to divide it by itself. So I have to divide by 6. What I do to the top, I must do to the bottom. So 36 divided by 6 is 6. So 6 over 36 is equal to 1 over 6. 7 over 49, so I'm going to divide everything by 7, so I can have 1 on the top. And 49 divided by 7 is 7. So this would be the same as 1 over 7. So we've not found the 1/5 that we are looking for yet. Okay, so we'll keep going. So looking at B, 8 over 24. Well, to turn 8 into 1, I have to divide it by itself. I have to divide it by 8. And 24 divided by 8, because remember the golden rule, what we do to the top, we do to the bottom. Well, 24 divided by 8 is 3. So this will be 1 over 3. So my answer has got to be A by default at this stage. I hope you can see that, but we're going to work our way through it anyway. So I have to divide the top by itself. So I have the number 1. So 6 divided by 6. But if I do that, I have to divide the bottom by the same value as well. Remember the golden rule. What you do to the top, you do to the bottom. So 30 divided by 6 is going to give me 5. So we have our answer A. 6 over 30 is equivalent to 1/5. So comparing fractions. There may be times when you will be asked or simply need to identify which fraction is the largest, and this is known as comparing fractions. You can only do this if the fractions you're working with have the same denominator or bottom number. We call this in mathematics having a common denominator, where the bottom numbers are the same as each other. We have three examples that we're going to take a little look at. Example 1, which is the largest, 9 over 24 or 4 over 12? Now you might be tempted to just take a guess at this, and I would urge you not to do so and encourage you to show your working out as well. This is generally a 2-mark question in an exam, and for 2 marks you need to show some form of working out. So let's just take a little look. Now, if I look at the very first question, 9 over 24, here, or the very first fraction I should say, sorry, 9 over 24, I could divide 24 by 12, by 2, sorry, to get to 12, so we'd have the same bottom number. But that means I have to divide the top by 2 as well to get me 4.5. Now, since that would be a decimal on top, that's not something we can do, so that's not our option. Can't change this one. I have to focus my effort on changing this one. So to turn 12 into 24, I would times it by 2, which means I also have to times the top by 2 to get 8 over 24. So now I'm comparing 9 over 24 with 8 over 24 to determine which one is the largest fraction. So since I know I've got 24 at the bottom of both fractions now, a common denominator, I can ignore that for now. I can ignore the bottom and just focus my attention on the top values here. And we are looking for the largest fraction, so we're looking for the largest top value or numerator, 9. So this fraction here, 9 over 24, is our largest in that particular example. Now, we've already made a start accidentally on the next one. I could, in point of fact, guys, if I wanted to, I could multiply this by 2 to get 14 over 16. And since 14 would be bigger than 10, that would make this fraction the biggest. Or, as this animation shows, we can actually just divide this by 2 instead. So let's work this one through. 10 divided by 2 is 5, which incidentally is still smaller than 7. 16 divided by 2 is 8, giving us a common denominator. Okay, and we can see, oh, there we go. We do have now the two fractions with a common denominator here. Okay, we can see that this numerator is bigger than this one, and therefore this is our largest fraction, our largest value fraction. Now, sometimes I like to give you in exams something a little bit more complicated, so they may look at 3 fractions or sometimes even more, okay, for you to work with. And let's just take a look at that. So we've got 3 different denominators. We need a common denominator, a same denominator for all of those fractions. And we've got options here, just like we had options in example 2. I could times this by 2, okay, and have 70 at the bottom. I can times this by 10 and get 70 at the bottom. And this is already 70 at the bottom. Or I could times this by 5 to get 35 at the bottom. And I could divide this by 2 to get 35 at the bottom. Or I could divide this by 5 and get 7 at the bottom. Divide this by 10 and get 7 at the bottom. So it doesn't matter which way you go with that and which denominator you choose to use. Choose the easiest option for you personally. I think one of the easiest options here is to have 70 at the bottom. So I am going to double this fraction, okay, to give me 50 over 70. I'm going to times the middle fraction by 10 to give me 30 over 70. And of course, the next one is already over 70 anyway, so we don't have to do anything with that, although I do see a slight typing error. So I'm going to very quickly just correct that. I do apologize. That should be 40 over 70. Okay, so when we are looking at this, we are looking for the largest value at the top of the fraction. and we can see the largest value at the top of the fraction is 50. Okay. Now, when we do give our answer to questions like this, please remember we must use the original fractions given in the question. We must use the original fractions given in the question. If I give my answer as 50 over 70, it is likely I will only be given 1 mark instead of 2. Okay, to get both marks, you have to give your answer in the original form, which will be 25 over the 35. As always, we hand the reins over to yourself to have a go at some questions and put your skills to the test. So please do press pause. Make sure you copy and complete the following questions and then press play and we'll go through the answers together. Give yourself plenty of time to do this. It's not a race, it's not a competition. Press pause now. Okay, hopefully you've given yourself plenty of time and you're ready for the answers. And if not, press pause again. Okay, let's just take a look and see what is going on here. I'm looking at the very first example, top left-hand corner, which is biggest, 6 over 8 or 6 over 24. So again, I need to write these so they have a common denominator. And to do that, we need to find an equivalent fraction. Now, just like the previous slide, we've got options on this one, okay? So we can times this by 3 to get 24, which means we times this by 3, give me 18. So of course, then we can see that this would be the largest. So we've got our animations to do exactly that. And we can see that 18 over 24 is the largest, but as always, when we're answering this question, we must use the original fraction from the question. Let's take a look at the next question in the top right hand corner, which is the largest, 4 over 20 or 18 over 30. Okay, so again, it's a 2-mark question, so do show some working out. Okay, now I can't turn 20 into 30 and I can't turn 30 into 20, so we have to find a number that's common to both of them, and I think the number 10 would seem a good number to use. So if I was going to turn 4/20ths into something over 10, well, I'd have to divide by 2 because 20 divided by 2 would give me the 10, right? So 4 divided by 2 is 2, 20 divided by 2 is 10. Now, 18 over 30, well, 30 divided by 3 is how I would get 10, which means I have to divide the top by 3 as well. Remember the golden rule here, what we do to the bottom, we must do to the top also. Okay, so this now gives me 2/10 or 6/10. I think clearly you can see, you can understand or notice that 6/10 is going to be bigger than 2/10. Okay, but we must use the fraction from the original question, which was 18 over 30. Next question, the bottom left hand corner, which is bigger, 4 over 12 or 40 over 60. Now, again, there are lots of different ways to do this, lots of different common denominators we can use, but we want to try and just change one of the fractions if we can, rather than both of them. And we can do that by multiplying the first fraction by 5. Since 5 times 12 is going to give me 60. And 4 times 5 is going to give me 20. So now we can see that 40 over 60 is going to be bigger than 4 over 12. Again, make sure you use the original fraction from the question as your answer. There's 2 marks for this, guys, for each one of these questions. So for the next one, this is a little bit more tricky. 9 over 45 or 48 over 80. Now, as I went through this, I realized I'd used numbers a little bit more tricky than I had intended, but 720 seemed to be the best option for our common denominator here. And to do that, we were multiplying by 16 in the first instance and by 9 in the second instance to convert our fractions so they have a common denominator. And this then tells me that the second fraction, 48 over 80, is actually the biggest value fraction. So the fourth one I felt was quite tricky. If you did get it correct, then well done. Give yourself a big pat on the back for that one for sure. But let's move on. When ordering fractions, we need to write them all over the same bottom number or value. And remember, we call that a common denominator, the same bottom number, a common denominator. We then compare or order the top numbers, that's numerators, so we can just focus on those. And remember the golden rule as you do all this, that what you do to one part, you must do to the other. So what you do to the top, you must do to the bottom, or numerator and denominator. When finding an equivalent fraction, you can only multiply or divide. And of course, we've got some examples for you as well. So we've seen these fractions already. We did speak about this one. We said we've got a number of options that we can use as a common denominator. We could write them over 7. We could write them over 70. We could write them over 35. Okay, whichever one you feel more comfortable using, use that one. Okay, but let's just talk about this one. We're going to write these over 70. We're going to double the top and also double the bottom because that's our rule. What we do to the top, we must do to the bottom. Gives me 50 over 70, which means for the middle fraction, we have to times by 10, since 7 times 70 is 10. And of course, then we have to times the top by 10 as well, give me 30 over 70. And the third and final of those fractions, well, we don't have to do anything with that. It's just 40 over 70. We can use this information to order those particular fractions, 30 being the smallest of the numerators, 40 being the next smallest, and 50 being the biggest of the numerators. But that's not our final answer, remember. Our final answer must be in the form of the fractions given to us in the question, which will look something like this. Okay, so just to clarify, our final answer must be using the same fractions that they gave us in the question. Okay. Example 2, write the following in order from the smallest to the largest. Again, we do call that ascending order. Ascending is smallest to biggest. You can think about this in terms of mountain climbers who like to ascend mountains. And then, of course, they like to descend mountains. So coming back down again from the biggest to the smallest is a descent or descending. Okay, that's a good way to think about that. Okay, let's dive into example 2. Write the following in order from smallest to largest. This is more commonly known as ascending order. Smallest to biggest is commonly known as ascending order. Biggest to smallest is called descending order. Let's take a look at what we've got going on here. We have 15 over 30, 12 over 18, 30 over 36. Please do remember that our starting point is to rewrite these fractions so that we have some equivalent fractions that all have the same bottom number. Again, we call that a common denominator. Now, I do know that 30, 18 and 36 are all in the 6 times table. I do know that 5 times 6 is 30. And so a good starting point would be to divide the first fraction by 5. So 30 divided by 5 will give me 6. 15 divided by 5 will give me 3. So again, 12 over 18. I know that 3 times 6 is 18, so I have to divide by 3 in order to get 6 as a denominator. 18 divided by 3 is going to give me 6. 12 divided by 3 is going to give me 4. 4 over 6. Lastly, I know that 6 times 6 will give me 36, and therefore I need to divide by 6. 36 divided by 6 will give me 6. 30 divided by 6 will give me 5. So I can take a look now at the numerators, and as it happens, these are all in the correct order already. Sometimes that may happen. Okay, but we've got the 3, the 4, the 5, the smallest to the biggest. And of course, this is going to form my answer. Now, please do remember, when we do give our answer, we must give our answer using the original fractions from the question. This is the third and final time where we turn things over to yourself. So you can press pause, copy and complete the questions by writing each one of them in order, smallest to biggest. Then remember to press play and we'll go through the answers together. Now don't rush this, take your time. Okay, it's not a competition. So press pause now, give it a go. Well, hopefully you've given yourself plenty of time on those questions, but if you haven't and you still need some more time, press pause again. Okay, so let's go through some of these answers now. And now I'm looking at the very first set of questions and I'm looking at the denominators. That's the bottom value. And I can see we've got 27, 45 and 54. I recognize them all as being part of the 9 times table. So I'm going to try and write those 3 fractions over 9 if I can. I know that 3 times 9 is going to give me 27. So I'm going to divide the first fraction by 3. 18 divided by 3 is 6, so I'll have 6 over 9. I know that 9 times 5, or 5 times 9, is 45, so I'm going to try and divide by 5 if I can to get 7 over 9. And lastly, okay, I'm going to divide by 6. 6 times 9 is 54, so 24 divided by 6 is 4. 4 over 9. Now I'm going to take a look at these and I'm going to look at the numerators and I'm going to put those in order first. So the order will be 4, then 6, then 7. So 4 ninths, 6 ninths, 7 ninths. We must use the original fractions, okay, from the question. So above the 6 ninths, I can see 18 over 27, but the 4 ninths is first, which is 24 over 54. Followed by the 18 over 27 and 35 over 45. So that's my final answer. Now, please do remember that if you give this as your final answer, just down here, this will give you 1 mark out of a possible 2. For the second mark, you need to also use or give the answer using the original fractions. Okay, let's take a look at the second question. I am looking at the denominators, they're the bottom numbers. I recognize them from the 7 times table. Since I know that 3 times 7 is going to give me 21, I'm going to divide the first fraction by 3. And I know that 7 times 7 is 49, so I'm going to divide the second fraction by 7. And I know that 8 times 7 is 56, so I'm going to divide the second fraction by 8. And I'm going to put those into the correct order. I'm looking at the numerators, they're the top numbers. As I do this, I know that 2 is the smallest, followed by 3, followed by 6. Okay, so we have our order, but that's only 1 mark out of a possible 2. To get the second mark, we need to use the original fractions from the question. There we go. So that will ensure we get both marks. So please do make sure you are showing working out a method throughout those particular kinds of questions. Okay, that's really, really important. Remember that the examiner is looking for opportunities to give you as many marks as they can. Examiners are not looking for opportunities to deny you marks. They're looking for opportunities to give you marks. So you've got to work with them and give them something to give you marks for, if that makes sense. So to summarize, an equivalent fraction is where we have two or more fractions that have the same value as each other. To find an equivalent fraction, we can only ever multiply and divide, and that the golden rule is what you do to the top, you must also do to the bottom. When we do compare or order fractions, we must have a common denominator. That means the bottom number must be the same as each other before we begin. In the next video, we're going to apply your knowledge and understanding to adding and subtracting some simple fractions. At some point in a few videos' time, things are going to get a little bit more complicated when we talk about adding and subtracting fractions. So you're going to not want to miss this one because it's going to lay the foundations for those more tricky questions that you're going to face in the future.